Here we have a Sega Monaco GP minicab. Last time I powered this up, one of the boards wasn't working and the accelerator pedals got a fault, so now I just need to work out how to disassemble this and get the accelerator pedal out. Get the main wire out of the way. So yeah, that's bolted in from the other side, that might be tricky. I want to get that out now. Probably the optos that are faulty on it, to be honest, and I'll have a look at those, test them and replace them if need be. Okay, here's my custom test rig for Monaco GP boards. Basically we've got a steel frame with board mounts on it. We've got the LED scoreboard and the memory board all attached to one system. Let's see for boards. I haven't actually got a soundboard in at the minute, I'm just testing the video and the main boards. Also, this requires a custom built video amplifier as it outputs a very low voltage video signal, which is compatible with the original Japanese monitors that we found in the cab, but it doesn't actually work with normal monitors or test bench monitors, so I've had to add this little custom designed video amp. Quite large boards. For anyone who's not seen a Monaco GP before, basically it's an entirely logic design game. There's no CPU on it, so that actually makes it very fast for its year because there's no CPU lag. It's actually a very quick game. It's actually really fun to play. The game's just sat in attract mode there. I do have the ability to coin it up. So if we look, it's just going to start and run. The time's going to count down. Actually, I've added a resistor across the accelerator pedal so it just accelerates. But I do have the pedals there, and there's a steering wheel and gear shifter on the original panel there, so I can actually test everything on the bench. Well, I'm trying to get the steering working on the test bench, and I've noticed basically the optical output, or the pulsed output from the optical drive, it's not doing anything. Just sat low, so I need to have a look at the steering opto board on this one. Okay, here's the steering PCB. Basically it's a pair of slotted optos, looks like it's transistors to drive the outputs of those, two different inverters and a Schmidt trigger. I think the trigger is, yes, the trigger is going to the output, yeah, so basically I think the signal from these are inverted and then passes this trigger, which then passes pulses to the game board. The optos appear to be working, because if I interrupt the opto, can't do it without blocking the screen. If I interrupt that, you'll see the LED go off, and the same with the one at the top. Yeah, so the optos are okay. So I think that means also the inverter is probably working. So it's probably this trigger that's bad. Okay, I've replaced the trigger here, and I've also replaced this transistor here which had a leaky junction. Let's give it a try. Okay, we can now steer. Okay, next up is the accelerator PCB, which consists of two optos and some transistor drivers. So yeah, I've hooked up to this board to test the optos out using my meter, and there's nothing happening at all when I interrupt the optos. I can see one of them is actually a visible red LED rather than infrared. The other one is not doing anything, so that one's absolutely 100% dead, and that one I think is just emitting but not detecting. And one problem I've got is I do have optos, but that's what they look like, the common slot optos. These are strange ones with leads coming out the side and a different package. Maybe see if I can try and adapt one of those in. Might have to drill through the PCB or something. I've not managed to find anything suitable as a replacement for these optos, so what I've done is I've taken a separate IR emitter and an IR photo transistor, and I've actually, as you can see, that is focused to the back of the photo transistor, so that's nicely lined up. The output of the board is practically 0 volts. Now if we just interrupt the that, you can see the IR bouncing off that. We'll just interrupt that beam and we can see we're getting pretty much 5 volts. I'll take it away again. 0 volts. So hopefully that will be a suitable replacement. Okay, so the beam is blocked. The car's trundling along. Remove the card, and the car accelerates. Okay, I think that's going to work. Okay, I'm just making up the upper opto assembly the same, emitter and photo transistor. The tricky bit is going to be, because the previous plastic housings basically touch together to align this, I'm going to have to fiddle around with it to get it to line up. I might need to insulate these so that you don't get basically the beams crossing over and affecting the other. So I might have to put some cardboard slits between them, but I'll play around with that now, see if I can get it working reliably. Okay, the upper pair is installed, and as we can see, both are correctly focused to the back of the photo transistors. So on the second pair now we're looking at 0 volts. Just insert a piece of cardboard, and we get, oh, can't see that, 5 volts. Take that away. 0 volts. So that looks like it's going to work. And one problem that I've got is that this opto interrupter just basically moves around there, because previously, obviously when we had the slot optos, let's get one, the interrupter would have sat in the slot, so it would have actually been raised up, and the one at the top would also have basically held it in place. So I need to adapt something to stop this from rattling around so it actually operates smoothly. So I've cut out a little plastic spacer using the Dremel and glued it in. That seems to line up nicely now. Let's give it a test. Let's start a game and test it out. So we started and it's standing still. Just apply some pressure. Let's move it slowly. Push full down. So that's slow, and that's fast. Slow, fast. Yep, working perfectly. As with any monitor that's not been used for a while, I like to just clean the area around the anode cap to make sure there's no moisture and there's not going to be any arcing. Important thing for a cab that's going to an exhibition, I got the upper cooling fan working, which was previously jammed. It seems to be nice and smooth now actually, and quiet, so that's good. I'm just checking what voltage is coming out of those bulb sockets. I need to get some lamps in there. That's the next job. Unfortunately, Monaco GP uses these strange acorn bulbs which are pretty much unobtainable. So what I'm going to do is have a go at adapting some 555 bulbs by bending out the wires and then heat shrinking them over the metal tabs on basically the acorn bulbs were attached to. It's actually a similar attachment method to the real acorn bulbs, but obviously 555s are a lot easier to get hold of and therefore easier to replace in the future as well. So I'll give that a try. Well, my attempt with a 555 bulb did not work because I couldn't solder any wires onto it. It just wouldn't, the wire links on the 555 just wouldn't take any solder. I've used one of these old brass 44 bulbs, as they're actually very easy to solder onto. So I've put a couple of wire links on, I'm just going to trim them down, then try heat shrinking them onto the pins. Okay, so my second attempt at a homemade acorn bulb worked. So the 44 is definitely a better bulb to use. I'm going to do the remaining 5 now, and then it should look pretty good. And that's all 6 bulbs done, ready to reassemble the front panel. There we go, look at that. I don't think you can get any more retro than the glow of these LED displays and incandescent bulbs. Looks really good. Okay, this is the Monaco GP monitor. I'm just separating the chassis from the tubes so that I can do a recap and service of the monitor. It's a bit dirty as well, so I'm going to clean it all up. Right. I'm just working on this Monaco GP chassis on the bench, just replacing all the capacitors with Panasonic capacitors. I've also cleaned it up and I've done some dry joint repairs, quite a few dry joints around this area here. So that should be good to go now.